you have 3 details to worry about, right? You have to worry about recognizing the problem, right? In other words, when or how or can you recognize that you need a summation? Second is formulating. Putting it together. Not calculating, because that's the last one. Formulating is actually writing it out, but then the actual calculation itself. Calculating. Okay. So this one's short, so we can say it, but then who wants to please tell me, when do you recognize it's a summation? What's the biggest hint there? I normally give you 3 pieces of information. Or you can even tell me, how can you recognize when I phrase it as a summation problem? If you are having trouble for a moment going, okay, well, I really don't know that either, that's fine. A more generic question is, what kind of problem do you only see a summation in? So again, those questions were the most general. When do we ever do a summation, right? What kind of problem does it only fit into? That's 1. And then 2, what kind of verbiage or language do you read, hear, however, or recognize when you actually need the summation? That's 2. And then 3, the most straightforward, it's what details or numbers do I provide that you know it's a summation for sure? Someone type their answer out. Perfect. So thank you, Jackie. The biggest one, right? So I'll say 1, 2, and 3. So the moment you see research suggests, blah, blah, blah. In other words, some type of growth. Then you know it's summation, right? And once you recognize that, then you can go, oh, okay, cool. I know that whatever that's going to be driving my income will be summation based, right? I will already do number 1 right here. Basically, we only see summations in modeling problems, right? You're not going to all of a sudden see a summation in a finance problem, in the sense that I will go, hey, it's compounded monthly, and then all of a sudden you got to do a summation for this. No, it doesn't work that way, right? So research suggests, and then normally with research suggests, I give you some kind of initial, some kind of cost, and some kind of growth. And with those, you normally get 3 numbers. Right? And those 3 numbers correspond with the above, right? Some kind of initial, cost, or growth. So if you see/read extra details about them, you may not need them, right? That doesn't mean that I'm going to inflate it such to confuse you or just have you dig out a whole bunch of dirt before you get what you need. However, you still need to be able to recognize those 3 details, right? So initial cost growth, the formula, or formulating, right? Remember, it's something of this fashion. Alpha times beta to the I minus 1. And then normally you have some type of number out here. Let's just call it Z, that has some kind of dollar value for it if you want to make money, right? That we already saw when we did it 2 weeks ago when I first introduced the summation as a whole. Now, when you're calculating is different. Calculating, you could either do an actual summation, or you can do a single day. Right? An example of that is if I say, e.g., suppose on day 1, you reach 10. Research suggests a growth of 3. Growth, not brother. Okay. Paid 50 cents each person. Okay. So based on these 3 details, right? 1, 2, and 3, right? Your summation should look something like this. 0.5 parentheses I equals 1 to n. You start on day 1 of 10. So yeah, I may have written the number 1 there, but that's day 1, right? Contextually sound and unrelated to the problem in terms of the numbers you calculate. Growth by 3, I minus 1, done. Now my question is, how do you know when I'm asking for a summation or a single day? Now we already know what that means, right? Single day is like a single day of the month. A summation is a series of days in a month. What is the verbiage or context that you're looking for so you don't confuse them? All right, no written answers, that's fine. All right, so again, the question was, if I ask for a single day's worth of how many people you reach or how many likes you get or how many views you have versus a series of days, how do you distinguish the both? The calculation is similar, just a little bit altered between the two. One of them is really easy because it has the answer in the phrase. So it's either summation or single day. What's the verbiage that you're looking for so that you can be, I know that I'm not doing a summation for sure, or I know I am doing a summation. Heard some people come in, so let me just mark them. Okay, so something like within first 4 days or on day 6. All right, cool. So if you are looking at the chat window as well, I mean, I know I already flipped to it right now as you're watching, but you can see Olivia said within the first 4 days or on day 6. So single day has the answer written within it, right? It says single day, day 6, or day 5, day 30, day, whatever the case may be. but it blatantly tells you that it is 1 day, right? And then within the first 4 days, it tells you a series of days. And within the series of days, you always start at 1. So you don't have to worry about that. All right. So I'll use those examples as well, or those numbers, if it tells you summation. No, I need a different color. Green, here we go. If this tells you in the first 4 days, right? Whereas this one will say on the 6th day. You know for a fact it will be one or the other, and it must be phrased as such. Otherwise, it won't work. Otherwise, you won't know which one you're doing. And the other hint, though it's more of a nuance, is that since I said in the first 4 days, you know that you're going from I equals 1 to 4. Whereas on the 6th day here, this is no summation. I've written this out before in some shape or form. Singular days are non-summation forming because it's a single day. Therefore, when you have no summation, you simply take down exactly what was given to you, and you plug in whatever day was there. Here in this case, since it is the 6th day, it goes straight down to 6 here, minus 1, and then you calculate this. And remember, this gives you different color. This portion gives you the amount of stuff, whatever it may be. Remember, likes, views, people, hits, traffic, right, on a website. And then this will give you a monetary calculation, monetary. So think money, okay? Now, in terms of in the first 4 days, you always start at 1. That corresponds or coincides with the fact that I've taught you all to start at 1, right there. Therefore, when you rewrite the summation, the only thing that's different, 10 times 3r to the minus 1, is the fact that whatever day I give you last, it goes right here on the top. And remember, that is the upper limit of your summation. Now this one, it's the same exact thing as this. It's just that you have to remember you have to cycle through your days, right? In other words, if it's 4, you have to do it 4 times, and then you have to also remember to add them in between. Minus 1 plus 10 times 3 minus 1 plus 10 times 3 to the minus 1. And again, you have your days 1, 2, 3, 4. And again, the easiest way to calculate this is 1 at a time, right? This is 10 times 3. No, 10 times 3 to the 0, which is 10. 10, 30. This should be 90. This should be 270. And then when you get these numbers added up, right, your total number of things is whatever this summation is. 3 times 3 is 9, 9 3 is 27. Okay, yeah, no typos there. So we got 270 plus 30, which is 300, and this becomes 400, right? 400 objects, whatever they may be. Actually, I'll just underline objects. Now, to get that for a monetary, right, you gotta multiply this by 0.5. Where did 0.5 came from? It came from here. And then how did you know it was 0.5 right here? It is what you were paid right here, right? Everything will always correspond to some detail. So you'll never have to make up anything on your own. Details will always be given. The one exception to that, if you happen to recall, is when we first learned about growth by a percentage or growth by a multiplier, that if you didn't understand the rule, then of course you have to make up a number there because you chose to interpret the rule differently instead of what I taught you. And again, that's fine. It's just the only time you'd ever make up a number. Remember, those are the problems that say, hey, how much time would it take for your investment to grow by 110% at 6.8% compounded continuously? Or at what interest rate compounded quarterly would it take, you know, your investment to double in 20 years, that type of thing. So then this would be, I don't know what this answer is on the right here for the 6th day, but this one I can do in my head. So this one would be half of 400 is $200. So you make $200 on the first day. So you can see there's the 200 aspect, monetary, and then there's, you derive the monetary because you know how many people, things, whatever, came to life or fruition because of your summation, right? Danny, that answer your question about the summation? All right, cool. Now, the other thing, the last tidbit is that remember, up to here, no, I'll draw a line. Guess we won't do it that way. Right? The top half of this yellow, I'm sorry, I don't know why I said yellow, must be tired. The top half of this pink staircase, right? This is the component section. That is, you would see this part before the model, right? Before the model. That is very critical because you don't want to start calculating things for your model until you have a model, right? So in other words, if you have a question like this, right? The recognizing the problem, the formulating, that would correspond with all these hints right here, in addition to this purple formula that I have written out. The calculating comes only after you have a model. So that means that when you're doing a modeling problem, as I've given you here in your first hint, right? You're going to see it, you're going to recognize it, you're going to write out the summation, but you do not calculate anything until you have the full-fledged model, and then you'll see these questions. Again, you'll recognize that again, because if you look through whether it's our notes, my textbook, or the homework, you'll see that I make the summation, but I don't calculate anything until I have the full-fledged model. So that's one little detail. So that means also that when you jump into the summation and you get your, you know, your little component here, your little piece to your model, right? It's not to calculate immediately. Yes, it only requires this in a black box, but you do not calculate because then it will throw off your rhythm or your mojo, or however you want to think of it, right? You formalize each piece to construct the model once you have the model as a whole, right? You have a model that asks for 4 components or 4 pieces, your model better have 4 pieces, so on and so forth. Then only after those follow-up questions, then you can see this phrasing here. In the first 4 days, how much would you blah, blah, blah. On the 6th day, how much would you make blah, 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 that. Okay, so that's the only other thing. So when you see a summation, it's not to attack it all at one fellow swoop. This is how to do it in one fellow swoop, but this is not how you do the models, right? You do it the same way, or at least I suggest you go about it the same way we've been doing it, right? You take one piece at a time, recognize, construct, calculate if necessary, have all of them, and then put it together, and then answer the follow-up questions after. All right. I'm going to flip back just to see if anyone has any other questions. But do you think we can go over with the modeling aspect too? So if you want to see a model like that, I'm just going to pull one from my textbook as an example, because I don't think everyone has seen that, or at least done it. So if you go to, where is it? Here it is. I am on my textbook. It is page chapter 3. Example 4 right here. It's page 29. Right, so this is the problem that we're gonna go over. So obviously you don't have to write this down, but I'll give you a moment if you want. Pull to the textbook, PDF, whatnot. It's mine. You'll see it looks exactly like this. And then you can see that obviously since this is an in-text example, all the answers are written out already. And then what I'll probably end up editing later is more dialogue in between these, but that's fine. We'll figure it out. By we, I mean I. Again, page 29. It's example 4 in the textbook. And then we'll just go over this. And I'll write it here too, so don't worry. So the question, further question is, question modeling problem, italicize. And then my answer to you is page 29, my textbook, example 4. Okay, so if you read that, actually, I'll just read it out loud one last time. Page 20. Where is it? 29. Okay, it says that suppose you have a different division in charge of social media for the travel business. You post your adverts, or you post AdWords. Should change that. Too many words there. You post adverts of the next airline deal at the beginning of each month. Research suggests once someone sees the advert, they send it to 2 other people the next day. Suppose the first day, your advert reaches 4 people. Okay, and then it tells you that you make 0.00025 each time the advert reaches someone, right? Or they click on it, whatever the case may be. Okay, the last one is, I'm sorry, the last one. The second, well, it is the last one. And it says you have an intern that is in charge of posting such airline deals. You pay them a variable amount each month, okay? So therefore, you have 2 components, right? 2 components. right? And then that means that your model must contain both. Now, this is the most simplest kind because I just said, hey, one of them is a summation, one of them is just a variable. But it's an easy example because if someone was reading this textbook on their own without teaching or in supplement, right, you should be able to understand what's going on without making it too complicated. So in other words, I hope everyone understands that your model, whatever it is, has to be A minus B, right? A is the summation, whatever it is, and B is what you pay someone. That's the most simplistic way to look at it, but hopefully you realize that there's two pieces. Okay, now if you read number 1, can someone tell me what the summation looks like for that one? So this is part 1. And you know that the summation is going to start off like this. What are the other numbers?
Is it 4 and 2?
Which one is 4? Which one is 2? Who gets the exponent and who doesn't? It is 4 and 2. We just need to know where they go.
Are you talking about the I or?
So the I always stays I, right? We're constructing the summation first. So what we need is, what are the two numbers that replace alpha and beta?
Oh, so like alpha would be 4 and then beta would be 2.
All right. And what made you know for a fact, beyond doubt, that alpha was example 4 or 2 was beta? You could pick either of them.
So
What was your
alpha,
biggest hint?
oh, the first day. The first
Right. So that might seem obvious with Daniel. Sorry, I interrupted you, Daniel. It may seem obvious when he's saying it out loud right now. Someone's going to mess it up, right? You must, right? My expectation is that when we're going together through this, right, that you have your notebook out, whether it's your same notebook or your same notebook that you've been using throughout the semester. If not, that's fine. But at least your previous math stuff is out, your formula sheet, your calculator, and something to write with, right? What you should also have out as of right now is a cheat sheet that you should be constructing, because despite this exam being open note and me even giving additional time, you want to spend 4 to 5 hours flipping through your flipping through your computer for my textbook to look for an example that's similar, or shuffling through your papers, or going through it in and out. No, you want to do this in, out, quick, done, right? So what Daniel said was absolutely correct. And again, sorry, I interrupted you as you were explaining. It said first day, right? If that does not register to you immediately, I'm talking like this, you should have that blank study sheet or whatever you use as study sheet and write that down. First day in the model means that this should be my alpha, right? So that's what we're looking for right now, because if you're good, you're good. You can ignore me. You're here just to witness. You're just here to see if I explain something in a different nuance so that you can pick it up and it's easier for you on the exam, whatever the case may be, right? Awesome. If you are struggling with this and you have not reached out to me for whatever reason, or if this is your question and you're thinking, oh my goodness, I'm so glad that someone else asked this question because I had this too, I just didn't want to say anything. And that's fine too. You must internalize this some way, somehow, because right now, more than ever, I'm not in front of you dancing, shouting, jumping, running up and down the classroom to make it a visual take. You are one step less of watching this in a passive way, like the YouTube videos I post. And I'm talking about the ones that are the lecture, not the ones that I actually have edited or have been helped assisted editing, right? Those are different. Those are like the 7 5-minute videos, basic summation structure and basic modeling structure. Those are good videos because they're short. But the ones that are an hour long or 2 hours long, right? That's like a podcast. You just passively listen, and you may be following along. But a student from my other section, for example, she's like, "Oh yeah, I tried having a notebook out, reading along, and everything. And even though you could pause it, you can't ask a follow-up question right then and there because again, it's not live." Okay, so you should be writing this down somewhere. Thank you, Daniel, by the way. Part 2 is just telling you that you're paying an employee of some sort. So just let P be payroll, be monthly payroll. Now, for those that are looking ahead, or you happen to have the textbook just right out there, and it says, hey, calculate how many total views. Again, those pieces, you should not be looking at those. Those are off limits until your model is done. But since we now have established this piece and this piece, you can make your model, right? Your model, which is the gatekeeper, if you will, that allows you to answer those follow-up questions, is the following. It is 0.00025 summation I equals 1 to n. I'm going to change the colors here. So we'll leave 4 for the initial. Use this light blue for the growth, I minus 1. And then this P, yeah, I can do it in black, that's fine, minus P. So this is your base model, as I call it. Base model. Thank you. Okay, base model. Now we can answer the follow-up questions. So it says, calculate how many total views of the first month's advert for the first 7 days. Then I ask you how much money was made. All right, how do we do that? What's the change that happens in our model right now so that we can do this? Or if you don't want to write it in a mathematical way, tell me, what do you have to do that involves that 7 now in the first 4 days?
The n, that's the upper limit, becomes 7 now.
Beautiful. So part, what is that, part A? If my chewing is loud, I apologize, or you can just tell me, hey, stop eating, because I'm munching now. So part A, right, upper limit is 7 now, upper limit. Is 7, why 7 was given. So the rewrite would be 0.00025 I equals 1. Let's use a different color here. 7 goes here, and everything else stays the same. 4 times 2 to the I minus 1, okay? And of course, P is nothing because the question, it doesn't provide you a P, and it's not even asking about the payroll P, okay? So for those that feel, oh my goodness, I don't know what to leave out, what to keep in, it'll tell you, it'll instruct you, okay? Now this is a mathematical answer, which I always admire for those that want to take it that way. Yes, it means you change the upper limit to 7, n is replaced by 7, okay? What does that mean calculated wise? You do what 7 times? You take this piece right here, and it's going to be written out 7 times. Four times 2, oops, apologies. 4 times 2, 4 times 2, 4 times 2, You know what? I didn't space this right. Sorry. Notice my writing's getting smaller. That was really lame. All right. No typos, just doing this so that it's better. 2 minus 1. 4 times 2, 3 minus 1. 4 times 2, 4 minus 1. 4 times 2, 5 minus 1. 4 times 2, 6 minus 1. 4 times 2, 7 minus 1. All right, since it is a summation, right, that's why we have these plus signs. Can't forget the plus signs. That's the point of this. An algebraic representation of how to, excuse me, add your numbers up. Where does this one represent? It represents the i's that you have to replace, and they cycle up one number at a time. There's 3, there's 4, 5, so on and so forth. Why do we know we go to 7? As stated earlier, it's the upper limit and it tells you your endpoint. The rest of this, you add it up and it'll give you the total number of views. And then once you multiply it by 0.00025, it'll give you the monetary. And then of course you can see the numbers, the answers I gave are right there. Now part 2 though, it says, suppose for the second month, research suggests that someone sees the advert, they send it to 4 other people the next day. First day of the second month, your ad reaches 4 people again. So part B, they tell you that first day of the month ever reaches 4 people again. In other words, you're saying that alpha is equal to 4. But what changed?
Hey, Professor.
Mm-hmm.
So for part A, like after we add up and multiply like all those numbers, 7
All right.
times, so we get that number and then we have to multiply that by 0.00025.
Correct.
And that gives us our total.
The total is a number before you multiply by 0.00025.
But don't we still have to multiply it though?
These numbers, let me scooch this down. So I guess my first question then is, can we get all the numbers that are supposed to be here? For example, this is supposed to be 4 plus so on and so forth. Can we calculate all those?
Well,
Everyone knows how to get there.
we calculate all those and we add them up.
Right, so that's the total number of,
And when we calculate them, do we have to put parentheses for the exponents or no?
if I were you, if you're calculating this on a calculator, this is 4 times 2 to the 2 minus 1. That's just 4 times 2. For this one, 4 times 2 to the 3 minus 1, that's just 4 times 2 squared. So if you do 4 times 2 to the second power on your calculator, there shouldn't be any need for parentheses. The parentheses only come in if you go directly, I need a different color. If you go directly from this expression, so then you would have to do 4 times 2 caret parentheses 5 minus 1
What would
close parentheses. But I wouldn't do that because that's overly complicated for something that you can just write in a simpler way. But I interrupted you. Go ahead.
because I thought you had to do like 4 times 2 and then exponent 2 minus 1.
But 2 minus 1 exponent is just 1, right?
Yeah.
So yeah, I would just do that. That's easier. See, this is 4 times 2 to the third. This is 4 times 2 to the fourth. This is 4 times 2 to the fifth plus 4 times 2 to the sixth.
Okay.
Does that make sense now?
Yeah.
Yeah, that's what I would do instead. That's the easier way. Right? You could do it the way what I've written in orange right here, but again, that's just unnecessary, I think, because everyone can simplify the exponent or subtract off one number and then they'll be good for the day. So whatever this total is, right, someone feel free to double check my math on there, should be 508. And then that's the total number of views. And then once you multiply that by 0.00025, then that is the dollar amount that was made from those 508 views.
When I multiply that, I keep getting 0.127, but the answer key says 0.064.
Let me try it. I may have done something wrong. 508 times 0.00025. Is 508 the correct summation?
I don't think so.
Okay. Someone double check that for me, please.
No, it is, sorry.
I also got 508.
Okay, so then that means I have something wrong. Let me fix that. 0.1027. All right, thank you for catching that. So if you just refresh your page, whatever web browser you're looking at through the PDF, it should be corrected now.
So it's
I don't know.
0.1.
0.127 or 13 cents. However you want to express it. Now this example didn't ask for a single day, but you can see that if you were asked for a single day, you wouldn't have to bust out the whole summation, right? You would just pick whatever day that was given to you, say 10, and you replace the I component with 10 or whatever day it is.
And then you wouldn't have to do like everything else.
Well, everything else only is if there's a series of days. If you only have a single day, there's only a single day. That's the only day to calculate, right? So if I said, do this for day 10, right? You don't go up to 10 because I would have said the first 10 days, as Olivia stated earlier.
So this is a single day?
This is the problem that's in front of you right now is a series. This is the first 7 days.
Oh.
Right, it'll tell you if it's a single day. They'll say 7th day only, or only 7th day, only 10th day.
So if it was only 10th day, then you would just do it once?
You do it once, but you got to make sure that it is 4 times 2 to the 10 minus 1, right? Don't pick a random number. Pick and use the number that I give you. 10th day, use 10.
But then would you have to write all those out again till 10?
So, okay, hold on. Okay, between those two statements, which one requires a summation written out for like this? So out of statement A and B, which of those needs to be in this format where you have to go up to 10?
The first one.
Right. So then the second one, how do you write it?
It would just be the same, but the top one would be 10.
So That is too vague of an answer for me to know that you're talking about the right thing.
That's 7.
Tell me what to write out right now,
It would be 0.00025,
right?
and then that thing.
No, not that thing. Not
Oh,
the summation.
You wouldn't do that?
That's the part A.
Oh, so what would you do for that?
That,
Okay.
right? Because summation implies day 1, day 2, day 3, day 4, day 5, so on and so forth. First 10 days
So would it just be
versus 10th day.
would it just be 4 times 2 to the 9th?
Correct,
Okay. And you wouldn't have, okay, cool.
right? Only use a summation if it is asked for you. If you didn't know what a summation or the difference was, right? You might want to watch my video on it again. And again, it's only a 7-minute video that explains it.
Okay.
Clear now?
Yep.
Beautiful. Now from there, now remember, for anyone else that's wondering, remember these numbers are not part of this example on the textbook on page 29. They're just more hypotheticals to make it easier to understand. Now let me write out what I had earlier for the second follow-up question, right? Alpha, they told you was the same, and by they, I mean me, because I wrote it. Alpha was 4, but then something changed. Beta changed, it told you. What did it change to?
Four?
Thank you. It did change to 4. So that means when you look at your base model, which is this, in the orange rectangle, that means that number 2 has also changed to number 4. Second month's model. Which is 0.00025. Again, back to n, yn, we're doing it for the generic month of the second month, right? I'm not asking for a direct calculation. I'm asking, hey, how does the model change? Minus p. So that's the model. That's how you can show it to me mathematically, right?
Solve that? Or
It also, all that, yes. All this in the orange rectangle.
how would you solve that again?
But you're not solving for it because I'm not asking you for a number to solve. I'm asking you, how does it change? It has changed from a 2 that was the growth factor to now the 4. That's what's changed. I'm not asking for a calculation on this problem. If you notice most of the models, if there is a calculating portion, it is one question,
Okay.
right? You calculate all day and night, being in this class, being in a math class prior to this, and then if you have to, being in another math class after this, depending on your major and your DARs and whatnot to graduate, right? I am way more interested in knowing how you think and how you understand how things progress than calculating. Because if you want to calculate, a calculator can do it. Excel can do it. You can hire a monkey to do it. You can have someone that, you can have that number cruncher in your business, your department, your team, your cohort, whatever you want to call it. Anybody can calculate, right? You just tell them, hey, plug in these numbers and just give me an answer and then report to me. That's not enough. You all are capable of not only calculating, but understanding how things change over time. And with that essence, it will make you a stronger person analyzing anything, looking at anything, okay? So when you read this question, and again, I'll read it out loud. Suppose for the second month, research suggests when someone sees the advert, they send it to 4 other people the next day. As Jackie mentioned, it's like, oh, this is talking about your summation. It's talking about research suggesting. I tell you, for the first day of the second month, your ad reaches 4 people again. How does your model change? It changes like this. I then ask, what is the overall outcome of the model? Overall outcome is an increase. Why is it an increase? The reason is that if you compare this orange rectangle with the first orange rectangle, right? And take numbers out of the equation in the sense of how many days you've seen, how much you pay the intern, P, payroll. Ignore that. Just take it for face value. What grows faster? This one, first one, base model, or this one? And hopefully you'll recognize that it's the second one, because the other one had a growth factor or a base of 2, and this is now a base of 4, AKA the light blue, sky blue number was 2 here, and it has now increased to 4. If it's 4, it'll grow faster. Okay. When you look at letter C, it asks you the same kind of question. Suppose for the third month, part C, suppose for the third month, the research still suggests once someone sees your advert, they send it to 4 other people. So they're telling you that beta is still 4 again. But then it says on the first day of the third month, your advert reaches only 1 person, which means that alpha is equal to 1. Right? And then they ask you, how does the model change? So this is a number 1 here. This is now 4. I minus 1 minus P. Again, this is the third month's model. And for this one, the overall outcome is actually a decrease because it's obvious. How do you know it's obvious? Outcome. I just spelled outcome incorrectly in the last one. Let me fix that. Outcome. Okay, how do you know this is a decrease? Well, look at the 2 models, right? You got month number 2, month number 3. They're both growing at the same rate. But in the second month, you had a head start of 4, whereas this one, you only start with 1. So sure, they grow at the same rate, but who had more bulk, if you will, to start with? The second month. So if the numbers were being calculated, if you will, or whatever the analogy you want to make is, right? You'll see that the third month, there's a decrease because the growth rate is the same. It's just that one had a head start versus the other, right? It's as if, you know, every one of you run 10 miles an hour, right? In 1 hour, you can run 10 miles. But if I start, you know, at say, you know, 0, but you guys all start at a mile ahead of me, right? In 1 hour, I do 10 miles, you guys do 10 miles, but you've reached further because you got a 1 mile head start. I started at 0 miles, right? So that's how you know the outcome of the model decreases, because the second model has a head start, quote unquote, of 4, not because of the light blue 4, it's because of the green 4, right? It's because of this 4 right here. And then the moment that you approach the third month in this example, you start at 1. So I don't have a head start of 4, it's just a head start of 1, all right? What questions on example 4, if any? If you notice, a modeling problem that involves summations can only get quote unquote harder when I add more components, right? I give you a lease of some sort, I give you a savings of some sort, right? But the idea of the summation being in the model means that the summation itself is you're generating income. That is the object, the tool, the method, whatever you want to call it, that's making you your money, right? So whether you look at an example we did 2 weeks ago when I first introduced it, or the homework on page, I believe it's like 32 now because it dropped the page. You can see I provided more, what do you call them, components, so that you can wrestle through them. But the summation is just one piece of it, okay? I'm gonna flip back to see if anyone has other questions. How do you plug into the calculator? Okay, we talked about that, that's good. Other questions that we have in general, because that was, I already asked if there was any other questions for example 4. While I have you guys here, just remember to please do the student evaluations as soon as possible. Deadline is the end of this week.
For one of the sample exam questions, I
Sure.
have like a question about it.
Do you remember which number it was?
It was on page 45, number 3.
Okay, no problem.
Professor, where are the sample exam questions?
They're my textbook, starting on page 44.
So yeah, on number 3, I don't quite understand the like how would you write it? How would you write the expression for the model?
Sure thing. It is sorry, let me just write this down really quick so people know where you are. So if you're not doing this, that's fine, I get it, or you haven't done it, at least open the same PDF that we're on right now. Right, scroll down to page 45. It's actually technically the bottom of 44, but it's between 44 and 45. Sample final. Number 3. Page 44 and 45. Okay, and then Dan's question is like, hey, I'm having issues with the model right here. Now, before we even jump into the model, were you able to get each of the components okay, A, B, C, and D? And if not, which one is the one that's giving you trouble?
Just B. I don't understand the like how would you write the expression, the variable?
Right, perfect. So part B, it just tells you it's telling you that the employees are paid some finite amount less than $200,000 every month. So what happens is that this is maybe more mathematical than we have to get into. Yet that expression of let P.
Wait, Professor, is this the one that Lucia does marketing for? Is that the one?
Correct. Oh, sorry, I'm looking at the wrong one. It is page 45. Nope, thank you for catching that. I heard Daniel, but then I was like, wait, what? All right, just kidding. So 10% of the generated revenue. Okay, I see now. Okay, so if you realize that in part A, you make 0.20 or 20 cents per view, right? And then you have to pay 10% of the generated revenue. Let me write that out. 10% of generated, generated revenue. Hopefully you'll see that from part A, the generated revenue is this 0.2x, right? In other words, 20 cents for each view. 10% is a translation of 0.1 because we never take the percentage. And then if you recall, of means to multiply. So in other words, what you're subtracting off to pay these two underlings, as I described it, it's kind of funny, is you're basically going 0.1 times 0.2x, which means that it will be 0.02x, right? So this piece gets subtracted at the end of your model.
Can we just do the whole problem?
Okay, so part 1 has a variable amount of 0.2x, where what? Where x equals number of views, and you're expecting them to be less than 1 million, right? But you wouldn't write all of that in the model. The piece that goes into the model is just this, just like how in part B, the piece of the model goes right there. Okay, part C tells you that you have to put away money every month. So then it's just R future value of 5 million times 0.051.
So we're also not solving for anything in part A.
No, because they didn't tell you how many number of views you have.
Okay.
Right? So the only time you're actually solving something is when it's more or less involving an annuity. Because what happens is that if anyone happens to be looking at page 46 where the answers are, right, there's only a solution for parts C and D. All right. And even then, you technically don't have to quote unquote solve. You can create the model by labeling, but it'd be easier to get a number wherever you can, because it'll help you to calculate any questions that you potentially may have. Right, so if you're looking at parts A, B, C, and D, which we're doing right now, which are the pieces, the components to your model, the only time you actually calculate something is part C right here. Part A is just establishment. Part B is simplification, right? 0.1 times 0.2x is 0.02x, right? And then now that you're on part C, this is the first time where you can actually calculate something. That's a parentheses, 1 plus 0.51 minus 1. Actually, I'll use brackets, it'll be easier to see. Over 12, 360. So this is equal to 5,897.49. And then part D, tells you that it's a one-time payment and it's compound continuously. So you should be using this formula here. E to the 0.057 times, what is that, 20? And then I'll do this in a different color as well. This one comes out to be 239,864.27. So the 4 boxes align with the 4 pieces of A, B, C, and D, right? And what happens is that this costs you, nope, not that one. This one costs you money. This one's costing you money, costing you money.
Wait, does that
And this,
for the part D, you multiply that by 20? Where'd you get that from?
it tells you that you want to make 750,000 at 5.70% compounded continuously over 20 years.
Oh, okay.
It says it in part D. The 3 that have costs, those are the things that cost you, or those are expenses. And the one in green, it makes you money. So your base model is going to be 0.2x minus 0.18x. I'm sorry, I did that wrong. 0.02. Got ahead of myself. 0.20 points. Do this one in purple. 0.2x minus 0.02x, there we go, minus 5,897.49 minus 239,864.27. Daniel, I hope, I remember it was originally your question, but I hope I answered your question in terms of how to get the simplification for part B.
Yeah, no, you totally did.
Yeah, I got it.
All right, now the follow-up questions, right? This one, they tell you that suppose for the first month you have 4 million views, right? So this is question 1. They're telling you that X now is equal to 4 million. So what do we do here now? What do you do with this 4 million? And how does it pertain to this model? I'm sorry, our model. What do we do with this 4 million?
Do you plug it into the X? Into the
You
base
plug
model?
into, correct. You, for every single X you see, you plug in 4 million and you calculate it. And that'll give you the outcome of what it is. And then assuming that I didn't make any typos in the textbook, right? It's a positive outcome.
For
Good.
the
I'm sorry, say that one more time.
plug that in for the X's in the base model.
Correct. Right? they're telling you that X is equal to 4 million views. You labeled earlier, or at least the assumption was, right? You, whatever variable, whether it was X, Y, Z, whatever you use to represent the views, goes into each of those X's. You now have an expression that can actually be calculated, and you get your answer that way. And if anyone is thinking about it, yes, you can combine those X's to a simplified one so that you have to plug in only once instead of twice. Okay, good. For question number 2, I ask you, what's the differences between the first and second models respectively? You may describe in words or show mathematically and state in words. All right, no one's typing the answers. Just wanted to make sure I wasn't missing anyone.
You don't have to include part D in the second month's model.
D as in Delta, right? Not B as in boy. Perfect. No. So the short answer is that your second month's model, thank you for answering. If you guys haven't realized, I'm not going to do any more answer. It's your guys' review. So the faster you answer, the faster class goes by, the faster I can let you guys go. Or you can be like some of your classmates that just kind of bounced out. Right, you notice that you have the things that make you money, as well as the same things that cost you money. And you got this monthly recurring payment to make savings. And then what happens is that you don't need the negative 239,000, blah, 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 and so on and so forth, because it's a one-time payment. And then if you look back and you go, well, you didn't say it was one-time payment. Did I say it was one-time payment? Yeah, I technically did. I said this month only. But even if I didn't, the fact that it is compound continuously, right? If you're looking at your formula sheet, looking at the second row of formulas, that's compound continuously. That is one-time payment. You make that payment, you're done, right? We haven't learned any annuity that involves continuous or
So the answer would be the
sorry, go ahead.
The answer to the question 2 would be the difference between the first and second model is that the first one was compounded annually.
You would say that the first question, the base model, you're saying this does not follow.
And why is that?
Because not recurring payment.
Okay.
How do I know it's not a recurring payment? Because the compounding period is what?
I thought it was 20 years.
You thought that the investment's for 20 years?
Yeah.
It is. So the question says that you want to deposit so that you make that money in 20 years. So what that means is that you're going to put some amount of money in, and then the interest or the bank or the account, however you want to think of it, is going to grow in those 20 years without any further contribution to the account. And the reason is that you put in a sufficient amount of money so that over 20 years and the interest rate it's currently at, it will hit that goal in 20 years. Right? The reason that I asked in light blue right here, why is this not a recurring payment, is that the problem asks for compound continuously. Compound continuously problems, you deposit that principal once and only once. So it can be over 20 years, 100 years, a million years. But because the principal is deposited once you put it in there, you deposit and you forget about it, right? You don't touch it, nor do you contribute any more money towards it because the account's doing all the growing. Whereas an annuity, not only is the account growing because of interest, it's growing because you're continuously putting reoccurring amounts into the account. So the time frame is independent of whether it happens multiple times or not, right? It's more the compound period. And from the compound period, you surmise whether it's something that you're going to be putting away on a monthly basis or something that you put in a one-time basis. Clear?
Yep.
Okay. Question 3, it tells you to find the break even of the second month's model. So what do you do here then?
Set the second month's model to 0.
Perfect. And that 0 represents what again?
The break-even point.
Almost. Break-even point is what you're looking for. What does it mean when break-even? The break-even point is a number of items, in this case, what the heck are we doing? Views, that sets our model equal to 0. What does a 0 represent, right? If X is represented by views, or objects, right? This 0 can't be 0 objects because that wouldn't make sense. You're telling me that you somehow made money by earning 0 views. It's impossible, right? So the X is
it's when what you earn covers the cost.
right. So 0 what? 0 earning is the key word there. What are the units of
Dollars?
0? Yeah, $0, right? Because what will happen without a shadow of a doubt is that someone is going to solve this problem. And when they get their answer, they're going to write X equals, and they'll even remember to round up, and then they're going to tell me it's dollars. How can the X be the dollars when the X are the views? If it's $0 you're starting with, it can't be dollars, right? It's X things, objects, views in this case, whatever the case may be, right? That's just algebra, so go ahead and do that at your own leisure. And then the last one is...
Professor, though, on the answer key for part 3, it says 0 equals 0.18. Where does that come from?
Well, what is this simplified?
Oh, okay.
Perfect. And then what happens is that Where'd it go? Okay, and then the last one, it says that suppose business is going very well, and by the third month, they want to increase the amount of made per view from 20 cents to 50 cents. How did your model change? So now they're telling you in question 4 that your views go from original or crispy. Just kidding. That was a fried chicken joke. This is now changed to, what did I say, 50 cents? So it's now 0.5x. I should do that in a different color. So what does your model look like now?
Instead of the 0.2x in the beginning, is it 0.5x?
Beautiful, right? Because you still have to make money somehow. We have not adjusted how you're paying people. And of course, the monthly payment is still the same. Excellent.